Hello, we're ready for part 1 of the second part of chapter 4. This is titled Periodic Functions. We're going to stretch and translate graphs. Now, translate is simply another way to say shift in any direction. Translate a graph. You can translate it with an additive transformation. You can have a multiplicative transformation. We're going to primarily talk about, though, periodic functions. A function f is said to be periodic. A function f is said to be periodic if there's a positive number p such that f of x plus mp, where m is an integer, is the same as f of x. In other words, if you shift f of x to the left or to the right and it still looks the same, and that means it's periodic. It repeats over and over and over. This means that you have a repeating cycle. That's all that it really means. Here's an example. The amount of daylight. So, early in the year, January, you don't have much daylight. And in the summer, you have a lot more daylight. And then December, it gets back to it and it starts over. That's called a period of 1 year. That's how long the period is for daylight to start its cycle over. All right, a fundamental period. A fundamental period is the shortest length of time it takes to complete one full cycle. It takes to complete one full cycle. So let's look at an actual example of this. Alright, let me pull out a nice dark color so you can see it. How about a bright blue? We're going to graph a wave here. So start at -4, put a dot. And then go up to 2, -2, put a dot. So boom, and then it goes on down, so 2, -2, back to 4, 6, 2, and don't zigzag it, curve into the mins and curve into the maxes. This is a periodic function because it's a wave, it's a cycle, it continues to repeat. So is it periodic? It is, because it repeats. What is the fundamental period? How long does it take to get from where it starts to where it stops? From where it starts to where it stops. How long does it take to get through one full cycle? Well, a good way to think about this is to go from like max to max. How far is that? Well, from -2 to 6 is a total of 8. -2 to 6 is a total of 8. So that means from max to max, the fundamental period is 8. Or you could do it from min to min. How long does it take to start its cycle over? Well, it's still 8, 2 to 10. Or you could do it from mid to mid. How long does it take to start over? 0 to 8 is 8. I mean, there's a lot of different places. You could do it from -4 to 4. That's 8. That's how long it takes to start over. Alright, so here's my question. What is f of 2? F of 2, let's see here. At 2, you go down, it's -2. -2. Here's a question. What is f of... My question now is, what is f of 10? Do this without looking at the picture. What's f of 10? Well, what I want you to do is take the 10 and divide it by the period. Divide it by the period. And what was the period? How long to start and stop? 10 divided by 8. 10 divided by 8. 10 divided by 8 is 1 remainder 2. 1 remainder 2. You know what that means? Guess what? That means that f of 10 is the same as f of 2. It's kind of like the leftover. That means f of 10 must be -2. And is that the case? Yeah, we can confirm that from the picture. It may have helped at the beginning when we were talking about the period to do some choom, 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 choom. I'm up on the graph now. And choom, choom. See how you go from a hill down to a valley, back to a hill, and then, it starts over. Or you could start at a valley, go up to a hill, and down to a valley, and it starts over. That is the period. How long does it take to start over? So let's practice that new little trick we just came up with. Find f of 39. Find f of 39. We'll take the 39 divided by the period. 8 goes into 39 4 times. 8 goes into... That means it goes through 4 full cycles. 4 full cycles. 4 remainder with 7 left over. Well, therefore, f of 39 is the same as what, guys? The same as f of 7. Well, you can get that from the picture. Go up here. F of 7 right here. We'll just call it 1. I don't know if it's exactly 1, but we'll call it 1. You'll always be able to tell when you look at the graphs. All right, let's have a little fun here. Let's find f of, oh, I don't know. How about 98? F of 98. Okay, f of 98. Well, 8 goes into 98 12 times. 12 times with a remainder of 2. So guess what? That means we're really just looking for f of 2. Well, we've already done that a couple times. F of 2 was negative 2. And that's how it works. Just find that remainder. It's really not that hard. Find the remainder after dividing by the period. Pretty powerful tool. If you know the period, you can tell me a lot about the graph. What's the maximum point? What's the highest it gets? It's 2. What's the lowest it gets? Well, it's negative 2. What's the middle? That's y equals 0. That's the middle. How far is it from the middle to the max? How far is that? Well, that's 2. How far is it from the middle to the min? Well, that's also 2. That means the amplitude is 2. The height is 2. That's what we call the amplitude. All right, one thing we need to discuss, and that's the amplitude. This is an important word. Amplitude is similar to height. How tall something is from the middle to the max or to the min. Here's a formula for it. We call it A. We say it's top max minus min, little m, over 2. It's an average. That's all it is. It's an average. We say it's the distance from the middle of a graph to the max or to the min. Either one, it doesn't matter. Okay, where, let's see here. Big M is the max of f of x, and little m, he's just a min of f of x. He's just a little guy, he's just a minimum. Alright, those are all y values. Those are all y values when we're talking about amplitude. So looking at the last one we just did. So let's use it, let's find it with the formula for the last example. Max was positive 2. Minus min was negative 2 divided by 2. Well, that's 4 divided by 2, which is 2. I think it's usually just easiest to get the amplitude from looking at the picture. But if you want to do the formula, be my guest. Max minus min over 2. Max minus min over 2. Boy, we could make a song out of that. Alright. Okay, enough of that. Let's do some more practice. Okay, so copy this graph, the white graph up top. Copy it closely. That's your original function. Now we're going to start stretching and shrinking graphs. This is going to be awesome. Okay, sketch that graph. Okay, everything goes by ones. Everything goes by ones. Negative 2, up to 2, blah, 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 blah. Okay, get you a point. Okay, get you a point. There's a point right here at, oh, this is 2, 0. There's another one up here at 1, 2, 3, 4, 2. Okay, and what we're going to do is we're going to take this white graph, and down here, we're going to make it pink. But we're not just going to graph f of x, we're going to graph 2 times f of x. 2 times f of x. Now, that's the formula you might see is y equals k times f of x, where our k is 2. K could be anything. It could be 3, 4, 5, 6, 7, 8, whatever. But what happens here is the y values times 2. And the reason I know this is because the 2's on the outside, not the inside. Or, you might multiply it by k, whatever k is. So what does that mean to your amplitude? That means your amp doubles. Double it, double it. It goes taller. The period doesn't change. The period is still 2. I guess we should have said that at the beginning. Let's go back and look at the beginning graph. My bad. What's the period of the beginning graph? How long does it take to start and stop? Actually, I think I made a mistake here. Okay, go back to the beginning. How long does it take to get from min to min? 2, 3, 4, 5, 6. 6 minus 2 is 4. The period, guys, is 4. That's how long it takes to get through one full cycle. Or you could go from max to max. From 0 to 4 is 4. So the period's 4. The amplitude, max is 2, minus min is 0, divided by 2. That's 1. The amplitude is 1. Think about it like this. Go chung, 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 chung. From middle to max is 1. So the amplitude's 1. That's its height from the middle to the max. Or you go to the min if you want, whatever floats your boat. Now, let's go down to this first example. And let's realize that I made a mistake here. Actually, the period doesn't change, but the height changes. The period is still 4. It is not 2. Not 2. So let's graph it. The amplitude doubles. Alright, so instead of starting out at 2, what are we going to start out? We're going to start out at 4. Let me put this point up here. 2, 0. Take it times 0, 2. Man, Mr. Williams, get your head in the game. 0, 2 is what that should be. Instead of 0, 2, we have 0, 4, because the y values double. Do the x values change? No, they don't change. They just stay the same. Alright, so leave them alone. But then instead of going up to 4, 2, we're going to go up to 4, 4. Amplitude doubled. Look at that. Isn't she pretty? She is pretty. Okay. Amplitude doubles. Period was 4. Make that period 4. Okay, let's see if I can get the next graph right without screwing up. Okay, the next graph, okay, the 2's on the outside. So that means my amplitude still doubles. My amplitude still doubles. But now it's the y values times -2. Times -2. Also, careful, it's negative. That means we're going to flip over what? If the negative's on the outside, I flip over the x-axis. You got it. Good job. You guys are so smart. Okay, so the amplitude doubles. If I'm changing it vertically, does the period change? No, the period doesn't change. The period is still 4. So let's graph it now. Alright, instead of the original graph, which started up here at 0, 2, take 2 times -2, you get -4. We start at 0, -4. Alright, instead of -2, 0, well, it's still -2, 0. And 2, 0 is still 2, 0. But instead of 4, 2, it's 4, -4. There we go. That's what it looks like. It's been flipped. It's upside down. Been flipped. It's upside down. Okay, so in example C, it says y equals 1/2 f of x. Well, the 1/2 is still on the outside, so it still affects the y values. So we're going to cut the y values in half. Half of the y values of each ordered pair. Remember, we had this ordered pair up here. 0, 2, he was 2, 0. He was 4, 2. It helps to label a few. It seems to help you picture it. So half of the amplitude, but the period hasn't changed. The period hasn't changed. So instead of 0, 2, I'm at 0, 1. Instead of 2, 0, well, guess what? I'm still at 2, 0, because half of 0, last time I checked, is just 0. But instead of 4, 2, folks, we're at 4, 1. Oh, yeah. Look at that. 5, 6, 0. And negative 2, 0. Nice. Awesome. So that's what it looks like when it's squeezed vertically. It's squeezed vertically. It's shrunk vertically. All right, and now we get to the tricky ones. All right, y equals f of 2x. So now we're affecting the x values. Or generically, and this is the way your book will put it, y equals f of kx. All right, here's some rules about k. All right, if k is bigger than 1, that number is bigger than 1, then it compresses horizontally. It squeezes. That's kind of backwards, isn't it? You're like, well, if it's bigger than 1, it should stretch it. Not if it's on the inside. If it's bigger than 1, it squeezes it horizontally. And if k is between 0 and 1, if it's a fraction, then what's it do? It stretches it horizontally. It goes, stretches that way, and stretches that way. It pulls it apart like a slinky. Alright, so let's check out our number. Our number is 2. Is that bigger than 1? It does. So we are going to squeeze our graph. We're going to squeeze our graph horizontally. We're going to squish it. Squish it, alright? We're going to squeeze it towards its inside, if that makes sense. Think about it like this way. You're running twice as fast, so it takes half as long to get there. You're running twice as fast, so it takes half as long. So now the amplitude stays the same, not touching it. Amplitude is the same, but the period, guess what? It's cut in half. It's half of what it was. 1/2 times 2 is 1. So you're running twice as fast. It takes half as long to get there. Here we go. Let's sketch the graph. All right, 0, 2 does not change. But instead of getting down to 2, 0, it only goes to 1, 0 before it hits its minimum. So now this is 1, 0. We cut the x values in half. Cut x values in half. Cut x values in half. All right, so instead of 4, 2, it actually goes up to only what? Cut 4 in half, actually goes to 2, 2. And instead of 6, 0, goes to 3, 0. And instead of negative 2, 0, negative 1, 0. This was 2, 2. And there you go. See how that is? See, check that out, folks. 2 full cycles. 1, 2. 1, 2. Here, the period, though, is only 2 units long. The period's 2 units long. Hold on, Mr. Williams. The period was, what did the period used to be on the old graph? The period was 4. Well, that means the period up here should have been 4. Oh, my goodness, guys. You got to catch me on this stuff. You got to tell me when I go wrong. You guys just let me keep talking. Half of 4 is 2. The period is 2, guys. It takes 2 numbers, 2 x values to get through a cycle. Check it out. Up, down, up, down, up, down, up, down. How long does it take to go through 1 up, down, up, down? It goes from 1, 2 to 3. 3 minus 1, 2. 2 units. That's a period right there. Period right there. Here's a period up here. It's 4 units. Cut 4 in half. 2 units. 2 units. Man, I did not bring my A game today. Okay, let's try one last one. Now here, k is 1/2. So what does this do? This stretches horizontally, okay? This time, take your period and double it. Your period doubles. Your amplitude is the same, hasn't changed, but your period doubles. You got to do 2 times the old period. 2 times 4, 8. Your period doubles. So it takes 8 units to get through a cycle. Here we go. All right, let me label some ordered pairs up here to help us. 2, 0. Man, that's 0, 2. This is 2, 0. This is 4, 2. Okay. All right, so joom, joom. All right, so 0, 2. When you take 0 times a half, you still got 0. So 0, 2. But instead of 2, 0, you got to double everything. So instead of reaching its minimum at 2, we're going to reach our minimum at 1, 2, 3, 4. Joom. It gets stretched like a slinky. All right, instead of going up to 4, 2, it's going to go up to double the 4. It's going to go up to 8. 1, 2, 3, 4. That's 8, 2. And then instead of 6, 0, double the 6, it's 12. 9, 10, 11, 12. All right, instead of negative 2, 0, double it. It's negative 4, 0. It's been stretched like a slinky, like a magnifying glass would stretch it, make it appear bigger. All right, that is what we do when we stretch and amplify graphs. Last little thing I want to talk about here. All right, a periodic function has period P and amplitude A. So that's its period. Its period is P, its amplitude is A. I'm not giving you numbers, those are just variables. Those are just variables, okay? If there's a K on the outside, what's that do? Does that affect the amplitude or does it affect the period? If you're affecting the Y values, what are you changing? The height or the horizontal shape of the graph? You're affecting the height, so it affects the amplitude. You take K times A, the original amplitude, but you leave the period alone. It's the same. Okay? If K is on the inside, now what? Well, now it's the period. It's not times K, it's divided by K, because the inside's kind of backwards. And the amplitude this time doesn't change. The amplitude doesn't change. All right, so here's the deal. I'm going to give you some function f of x, and I'm not even going to tell you what it is, because I'm mean. I'm just going to tell you the period is 7, and the amplitude is 2. Period is 7, amplitude is 2. And now I want you to modify f of x. Modify. I want you to transform it. Instead of f of x, do 3 f of x's. 3 f of x's. Tell me what the new period and the new amplitude will be. Well, I'll do the hard one for you. Since the k is on the outside, it affects it vertically, but not horizontally. So the period, that's still 7. Still 7. But the amplitude, oh, here's where we have a little fun. It's k times a, well, that's 3 times 2. The new amplitude is 6. The amplitude tripled. The amplitude tripled because we multiplied it by a factor of 3. All right, let's do the next one. Here, k is on the inside. All right, so what's our formula? P over k for period. And our period was 7. P over k. 7 divided by k, well, that's 1/3. 7 divided by 1/3, how many thirds go into 7? That's really saying 7 times 3, multiplied by the reciprocal. Well, that's 21. So the new period is 21. See how he's a fraction? Instead of shrinking it horizontally, it stretches it. So it takes 21 units just to get through one cycle. That's crazy, man. Okay, and now finally, the amplitude hasn't changed because we affected it horizontally. So the amplitude is still just 2. That's what it was originally. All right, and finally, what about if there's a 1/3 on the outside? Now who are we affecting? The amplitude or the period? The period has not changed. It's still 7. But the amplitude, well, it has changed. It's Ka. That's 1/3 times, what was the amplitude? 2. So the new amplitude is 2/3. It's been cut by a factor of 1/3. Cut. All right, it's shrunk. Okay, I think I've screwed you up enough for this first section. I've messed up a few times, but hopefully I got most of my mistakes fixed, and hopefully you were able to filter your way through my shortcomings and get some idea what it means to translate, shift, stretch graphs left and right. All right, we're gonna translate and shift in the next video. So look forward to that video. I'll catch y'all later. I'm out.